Okay, hello again, Addy. We are going to jump right into lesson number 50 today. And lesson number 50 is awesome because it goes over the decimal number line. So we're going to talk about tenths and maybe hundredths, we'll see. And then also dividing by a fraction. So dividing by a fraction, like this is part 2 of the lesson, but I think it's a really important thing. And you're going to see how it's done, and it's going to be so cool. And I put this here because I was like, oh my heck, Addy, we're doing lesson number 50. Can you believe it? Can you believe we have already done 50 math lessons this year? I mean, wow, you are going to be so far ahead, it's not even funny. All right, so let's jump right into mental math. I know that you don't really love this, but we're going to count by sevens, all the way from 7 to 84. And if you remember the way we do this, we are basically counting 7 times 1, 7 times 2, 7 times 3, all the way to 84, times 5, times 6, times 7, times 8, times 9, and then we'll do times 10, times 11, times 12. I think that'll get us there. What do you think? All right, so let's start with the first one. So we're going to do 7, 14, 21, 28. What comes next? Try and do it ahead of me. 35, 42, 49, 56. What's 7 times 9? 63, 70, 77, and 84. Okay, we did it. 7, 14, 21, 28, 35, 42, 49, 56, 63, 70, 77, 84. Cool. All right, let's do the rest of mental math now. This is going to be a breeze. We're going to start out with A. What is 8 times 200 plus 8 times 25? I hope these little GIFs aren't too distracting for you, but they're all clips from Elf that we just saw the other day, so I thought you would enjoy them. B, we are going to do 565 minus 250. Let's do C, 58 plus 27. Write your answer. You sit on a throne of lies. Remember that part? That was hilarious. Okay, how about $1.45 plus 99 cents? Now, if I were trying to do this in my head, I would add $1 and then just subtract a penny. What about E? What is 1/2 of $25? Write your answer. F, what is 5,000 divided by 10? Where are you going to move the decimal point, right? All right. Now, this is one of those long ones, right? We're going to start with the number 8 times 9. Now, add 3. Divide by 3. Subtract 1. Divide by 3. Add 1, divide by 3, and then divide by 3 again. Write your answer. This is gross. Do you think you could put all that in your mouth and eat it like that? Ugh. All right, we're going to jump into problem solving. Now, problem solving is interesting. It goes over a woman named Susan, or maybe a girl named Susan, began building stair-step patterns with blocks. Okay, so these are blocks right here. And she basically made some steps with the blocks. She used 1 block for a 1-step pattern. And 3 blocks, 1, 2, 3, for a 2-step pattern. Because if you stop there, you only have 2 steps. And then if you want to do 3 steps, you've got 4, 5, 6 blocks for a 3-step pattern. And then she wrote the information in a table. And you see the table on your homework, and I made a copy of it here. And they want you to basically finish the table, like write out how many blocks it takes for all of those steps, right? So let's see if you can figure out a pattern, or just kind of draw a picture. So like for 4 steps, you're going to, let's see, what if we had another step here? Okay, so we had 6 before, and now we're going to add 4 more blocks to it. So this one's going to be 10. So I gave you one of the answers. So whatever it is, it's going to be, there's going to be some sort of pattern. And I think what you're going to have to do is look at this number, and you're definitely going to need all of those blocks that you used before, but you're going to add a certain amount to the next step to get the next number. So look at here, for 1 step we used 1 block. Now if we want 2 steps, we definitely need that 1 because you need the 1 block. And what did you add to it to get 3? You actually added this number, didn't you? Let's do the next one. So if you are doing 3 steps, you definitely need all these blocks for the 2 steps. And what do you add to that for your next step? Well, you add this number again and you get 6. I don't know if that pattern works, but that kind of stood out to me in my mind. So see if you can figure it out. I'll let you pause it here and fill out the rest of the table, okay? And I'm going to move on to the new concept. The new concept is really important. And that's why I'm so excited. I'm almost as excited as Buddy the Elf when Santa was coming. Yes, this is so exciting. This new concept is basically you can locate different kinds of numbers on a number line. And basically you've already learned how to locate whole numbers, right? So you can get a whole number here, that's 0, obviously. A whole number here, that's 1. And a whole number here, that's 2, okay? You can also find negative numbers on a number line. I didn't put, well, I guess I do have a little bit of a negative number here. And you can even find fractions on a number line. Like you could figure out 1.5 is probably somewhere like right there, right? Maybe a little closer to, maybe, I don't know. We're going to actually figure that out in a second. And this new concept is basically you can also find decimal numbers on a number line. So decimals are on here too. So the trick to doing decimals on a number line is you figure out how many segments are in between 2 whole numbers, like the 1 and the 2. How many segments are in between? So let's count them. You've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 segments in between 1 and 2. Also 10 if you counted them in between 0 and 1 and all of that. So if you divide each segment into what it is, you could do it a couple ways. You could say, well, this is 1/10. Oh, that's too fat. I can't read it. It's too fat. Let's make it smaller. Okay, so 1/10. This could be 2/10. This could be 3/10. But what we're going to learn this time is instead of tenths, it's going to be in decimals. So this is going to be 0.1. This is 0.2, 0.3. And it's actually the whole number plus 0.3. So when I'm pointing at this one with the black arrow here, what would that be? It would be 1.3. That's the answer, 1.3. And this would be 1.4, 1.5, 1.6, 1.7, 1.8, 1.9, and then it switches to 2. Okay, so when a unit has been divided into 10 segments or 10 spaces, you can usually use the decimal form instead of the fraction because decimals are broken up into tenths. Because you've got tenths, you've got hundreds, you've got thousands. So because it's in 10 units, you can use decimals instead of fractions. Okay, so that is really cool. Let's do example 1. Example 1 says, what decimal line is represented by point Y on this number line? So here's point Y right there, and we're going to figure out what decimal it is. Now, in order to do this, we got to make sure, is this divided into 10 segments? Because if it's not, I would probably not do a decimal, I would do a fraction instead. But if it's divided into 10 segments, then we can do it. So let's count. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I tried to draw it as carefully as I could, but I know the segments are not totally even. So the distance from 7 to 10 has definitely been divided into 10 smaller segments. And this point Y, if you notice when I was counting, it's on the 4th segment over. So Y is actually equal to, it's 7 and 4/10. But you could also write that as a decimal, 7.4. So that's what they want us to do, is write it as a decimal. So it's 7.4. Okay, so that's all there is to it for that. So you did it. You learned how to find decimals on a number line. You did it. Congratulations. All right, now we're going to go over a much harder topic. So you're going to have to pay lots of attention to this part because this goes over dividing by a fraction. You definitely have to know this. Now, to do this, they're going to pose a question to us. And the question is, how many quarters are in $3? So let's say you were maybe at a vending machine, but it wasn't candy bars inside, maybe it was toys. And so it was a little bit more expensive, but it only takes quarters. And let's say there was like a toy that is worth $3 and you really want to buy it. How many quarters would you have to put in? So that's what it's asking. Now, we think of a quarter as 1/4 of a dollar. Remember, a quarter is 1/4 of a dollar because here you've got 4 quarters, 1, 2, 3, 4. It totals $1. So 1 quarter, which is 25 cents, is 1/4 of a dollar. So you'd have 1/4. You'd also have, this one would be another 1/4. This one would be another 1/4, right? You get that. So 1 quarter is 1/4 of a dollar. So to figure out this problem, how many quarters are in $3, the first thing we're going to do is figure out how many quarters are in $1. Okay? Because the problem of how many quarters are in $3 would be written like this. $3 divided by 1/4, because it's basically asking how many quarters, and this is a quarter, are in $3. So to figure that out, you would say $3 divided by 1/4. But we haven't learned how to divide fractions like that yet. So in order to figure out how to do it, first we're going to figure out how many quarters are just in $1. Now, here you would do the same thing, except instead of a 3 right here, you would have a 1 right here. So 1 divided by 1/4 basically is asking how many quarters are in $1. But you know how to do this already because anything times its reciprocal, remember that word? Reciprocal. Anything times its reciprocal is equal to 1. So when you divide something by a fraction and the answer has to equal 1, so if you divide 1 by a fraction, the answer is going to be the reciprocal of this. And the reciprocal of this is, instead of 1/4, it's 4/1. You switch the top and the bottom. So the answer to 1 divided by 1/4 is its reciprocal. So it's 4/1. And you already know that you can simplify 4/1 to just plain 4. Okay? So hopefully that makes sense, because 1 divided by any number is it's going to be its reciprocal. Let me do another one just to show you. What if we have 1 divided by 3/4? 1 divided by 3/4, the answer is going to be 4/3. It's the reciprocal of this, meaning you just switch the top and the bottom to get the right answer. Why? Because 3/4 times 4/3 is equal to 12 over 12, which equals 1. So that's why when you divide 1 by any fraction, you get the reciprocal for the answer. So now we know 1 divided by 1/4 is 4. So now let's go back to our original problem. How many quarters are in $3? So let's write $3 here, the number of dollars. And what we write here is the number of quarters in $1. The number of quarters in $1 is what we found, what we figured out. And the answer to that was 4. Remember, 1 divided by 1/4 is 4. And then you just do this multiplication problem, and your answer will be the number of quarters, I'm just going to put a Q, in $3. And the answer is 12 because 3 times 4 is 12. So, do you see what we did there? Let's review the steps. You've got the original problem, and the original problem says, how many quarters are in $3? So, to figure that out, you're going to say 3 divided by 1/4. But we haven't figured out how to do those yet. So, we're going to divide this question into steps. The first step is find out how many quarters go in $1. In $1, it would be 1 divided by 4. And the answer you get is 4 because it's the reciprocal. Now, since you know how many quarters are in $1, how many quarters are going to be in $3? Use this equation. Find the number of quarters in $1 to find out the number in $3. So $3 times 4 quarters in each dollar makes 12 quarters for $3. So if you had a machine that wanted $3 worth of quarters, you would have to put in 12 quarters. Let's do another one, okay? So the next one is the diameter of a penny. Whoops. The diameter of a penny is 3/4 of an inch. So if you have like a penny here and you measure it, 1 inch would be like 0 to 1 right there. And the penny would probably land right there at 3/4 of an inch, okay? So the diameter of a penny is 3/4 of an inch from there to there. Okay, how many pennies are needed to make a row of pennies 6 inches long? So you want to put a bunch of pennies side by side, like this, and you want this to measure 6 inches. But 1 penny only goes to 3/4 of an inch. So how many I know I'm going to need more than 6 pennies, right? Because if it were 1 inch each for each penny, you would need 6 pennies exactly. But it's only 3/4 of an inch. So it wants to know how many 3/4 are in the number 6. How many 3/4 are in the number 6? And then you would figure out how many pennies make that row. So the question is asking, what is 6 divided by 3/4? But we haven't learned how to do these problems yet. So what you're going to do is divide it into steps, okay? Let's just find the number of pennies in 1 inch. So instead of 6 divided by 3/4, like this, we're just going to do 1 divided by 3/4. And what's the answer going to be? The answer is going to be its reciprocal. So it's going to be 4/3. So there are 4/3 of a penny in 1 inch. What does that mean? Well, it's more than 1 penny because it's an improper fraction, but it's like 1 1/3 of a penny. Whoops. I should write them, I should do them side by side because I think they want the pennies to be touching. So more like that. But then it's cut off, right? So 1 1/3 of a penny. Well, I obviously didn't draw that to scale. 1 1/3 of a penny make 1 inch. But I'm not going to do 1 1/3 of a penny. I'm going to leave it in this improper form. So what we figured out there is that there are 4/3 pennies in a, oh, no, we just found out there are 4/3 penny in 1 inch, not 6. So we have more work to do. 4/3 penny in 1 inch. So now we have to use that information to figure out how many pennies are in 6 inches. So it's basically 6 times this amount, because this is how many pennies are in 1 inch. So we need 6 times that amount, 4/3. And then this is basically like 6/1 times 4/3. What do we get? We get 24/3. What's 24 divided by 3? 8. That's good, because that means we don't have to divide any pennies in half. So that's good that we got a whole number. So the answer is 8. So we found out that there are 8 pennies in a 6-inch row. Let's review how we did that. We take the original problem and we say how many 3/4 are in the number 6. So it's 6 divided by 3/4. That's the problem, but we haven't figured out how to do those yet. So we're going to divide it into steps. Let's find out the number of 3/4 in 1 inch. So now it's going to be 1 divided by 3/4. Now we do know how to do that, because the answer is going to be the reciprocal. So the answer is the reciprocal. Now, we're going to use that reciprocal to find out how many are in 6 inches. So there's 6 times as many. 6 times the number that's in 1 inch is going to be the number that's in 6 inches. And that comes out to be 8. Okay, so that's it. Hopefully you were able to follow that, because I know it's very complicated. So do the best you can on your homework. If you don't understand it, don't worry. No stress. This is what homeschool is all about, right? No stress. All right. I hope you enjoyed this lesson. Love you, Addy. Bye.